Okay, so this is the continuation from regression 3. So the difference between yang previous one too. For that one, we are trying to focus numerical values, but for this one, we have two types. The first one is called logistic regression. Normally, this is used to perform classification. And the other one is regression trees analysis, used to focus when you have ordinal values or categorical values that use number. Okay, later on we will look into that. What type of application that you can apply this method in order to model the data. Okay. Okay, so the logistic regression. In here, we learn how to develop algorithm to predict qualitative output. Qualitative output referring to categorical value. Contohnya male versus female, purchase versus not purchase. You have tumor, benign or malignant. So if we look at here, we have binary classification, two classes classification. Okay, let me. Okay, so this classification problem is modeled with the probabilities that are bound by 0 and 1. Contohnya, if you are male, you are here. If you are female, you are here. Since we have only two possibilities outcome, okay, or purchase or not purchase, or benign or malignant. So the objective is, given the independent variable, your dependent variable will be the probability for you to go to male or female, or purchase or not purchase. Okay, so this classification problem is best modeled with the probability that are bound by 0 and 1. Okay, so for logistic regression, this one is a special case of regression analysis in which your dependent variable, remember, your dependent variable, you model this one based on your independent variable. Okay, in regression analysis, your dependent variable is numerical, but for this one, you can apply logistic regression if your dependent variable is nominal. Nominal means categorical value, or you have ordinal scale. Ordinal scale means 1, 2, 3, and 4. So this is maybe excellent. This one is good. This is fair, and this is poor. Okay, so whenever you look at your dependent variable is categorical value or ordinal scale, you can use logistic regression. Okay, so this is your dependent variable. Okay, and no, this is your independent variable. Let me erase that one. This is your independent variable, and you use this one to model your dependent variable. So if you look at this one, this is the categorical value, okay, not numerical value. So when people say they are using logistic regression, meaning they are performing classification. Okay. So they said, why not just use linear regression? For this one, if you look at here, if your value for your y is always 1 or 0, and if you use linear regression, you will go to plus infinity or minus infinity. Okay, so the goal of this logistic regression is to basically compute the probability of you having 1 or 0. So the bound is between 0 and 1 only. Okay, so the logistic function f will be used in to compute what are the value that you get for this. Okay, so this is the normal formula. Apply this one. Okay, so remember that this one is your independent variable. This is your dependent variable. Okay, so but in this case, this is category or ordinal values. Okay, so we will use this one, the formula, but we use the logistic function. What is logistic function? Okay, logistic function is defined as you take this formula. This is have here can be defined by using this formula. So depending on the value of the z, where z is equivalent to this. Okay, so you replace this one with this value, then you can estimate the probability of having 1 or 0. So notice that all this value you can get, right? So first you need to do the regression first. So this is the coefficient of B1, B2, BK, and A will be estimated using the regression analysis. And then once you get this formula, then you plug this one in here in order to get the probability. That's for 0 or 1, in between 0 and 1. Okay, so that's how the logistic function used to compute. Okay, so in trying to perform the logistic regression, there are some data preparation, but this is common for all the type of modeling. We need to clean the data first, or we need to handle missing values. Either we delete that record or we have mechanism to have a default value for that particular missing values. And then what you will do, you will split the data into training and testing. So you train the model using the training data set. So this one is normally 80% to 20%. So 80% of the data will be used for training, 20% will be used for testing. Okay, so once you model the data, then you can test them, and then you can evaluate them based on other validation data set. So, so this is crucial in order to look at how many of your data can be predicted correctly. So these are the process. So what I will show, what in the next slide, it will show you this process. Okay, so they show you, okay, what happened when we read the data, and then how do we detect missing values, and then how we remove them, and then how we split them into training and testing, and then lastly, how do we evaluate or assess the predictive ability of the model. Okay, so this is the process. So let's take a look at the first one. Okay, so we have this data set in which we have the Titanic case, special case. So predict the survival of a person based on the ID, based on the uh, gender, based on the age, based on number of sibling, parents, ticket, fare, cabin, and where they join the ship. Okay, so for this data set, we get the trend. So basically, we are reading them. Okay, so when we look at the structure of the data set, we have the passenger ID, and this is the dependent variable. So based on the other features, they want to predict this one. So they want to model the data. So based on what they have, like this one, the name, and then the gender, how many, how old are they, and then how many siblings. This one, I think we have description for that one. Okay, so this one is number of parents, ticket number, passenger, and so on. Okay, so this is where they join the ship. Okay, so this is your dependent variable. Okay, so looking at all these features, if we check for missing values, we can say this one, because this is where is this? So missing value can be detected by using this one, not applicable. So if we perform this function, we will apply this one where we count the number of missing value using the sum, and we check on this data set and we apply. So we look at based on the feature, and we found that for the age we have 177 missing values, cabin 687 missing values, and then in bulk we have 2. So the rest are okay. We can also check the length or unique value that we have for each of the features. So over here, we are looking at unique value, and we count how many of them. Okay, so we apply this one to the Titanic data set that we have. Okay, so at this moment, we know already we have some missing value. So we need to settle that. How do we settle that? Okay, we can visualize where is the data missing. So we notice that the cabin and the age lah, and also here. Okay, so the rest blue means they are okay. So we can map the missing value here by using the mismap. Okay. Okay. One of the ways in order to handle for this one is that we look at whether that features are relevant with respect to the dependent variable. Okay, for this one, if you look at the value for the cabin, this is the cabin number. Okay, so we have around how many missing value? 687. So we can say that the name, and also the cabin number does not contribute to the dependent variable here. Okay, so over here we are saying that, okay, I will only select 2. Okay, passenger ID also is not unique, means they are not contributing to the survival of the person. So the name also, and also the cabin number, and also the ticket. If you look at the ticket here, the ticket is the ticket number. Okay, so the cabin number. So all of these are names that, so this one has no contribution to the forecasting model. So that's why for here we are saying that we only select the blue one. So the blue one is this number 2, number 3, number 5, 6, 7, 8, 10, and 12. Okay, so we ignore this one. Okay, so by ignoring features that are not relevant, we also can omit this one. So we can settle that one. But we still have the age here, and also the 2 rows here. Okay? So one of the ways to handle the age is we take the average age for all of the passenger that we have, and we put as a default age of the missing value. So how do we do that? So basically we are looking at we take all the age that we have in this data, okay, and we take the mean. Okay, so for all the missing value for this particular column, I will assign this average to that particular cell. Okay, so whenever they see not applicable values, means missing value, they will replace with the average of all the age that we have, not including the missing value. Okay, so this is how we handle the missing value, in which we take the average of the age and then we put that value into the missing values. Okay, so we can also check whether that particular features is a factor. So a factor is a label. Okay, so this one, the sex and also the impact are factor, meaning that they are label. Okay? So if you look at here, this is all label, and also this one. So this one we have male and female, right? Based on this data. So we see that this is factor, label, and this one is also label. Okay, so we can check that one also. Okay, when we look at the sex, this is label, right? So we can see how many unique label we have. The same thing also for the impact. Okay, so this one is we have 3 values. So if the value is C, then this is both 0. If this is Q, so this is 1. So this is similar to what we have. We change them into dummy variable. Okay. Okay. So if we change this one to dummy, that means your male, female. So if your data last time is, this is sex. If this is male, then this is 1, 0. Okay. If this is female, so this is 0 and 1. Okay, so similar to the 3 unique value that we have. Okay. Okay, so now we have settled the age. Now we have the impact features. We have 2 rows which has meaning. No, missing data. Okay, so it said here, okay, what I'm doing will be I will get all the data which is not missing value, and I will put them in my new data. So which means I will remove the one that has missing value for the IMAC. Okay. And then this one is simply erasing the column name. Okay, I will show you later on. Okay, so once we have this one, so we're done with the handling missing value. So basically this one is removing the row that contain the missing value for IMBAC. So now, how do we split them? So if you go back to the first time we read the data and look at the structure, we have 891 object. Okay, so we will divide them into training and testing. So we will divide them training and testing. Okay, so when we try to do the modeling, so basically this is getting row number 1 until 800, and this one is basically including all the features. Okay, so this is like two-dimensional array. Do you still remember? So when we have this, so the first one is referring to the index of the row. This one is the index of the column. So if we leave it empty, means all the column. Okay, so if you want to put the range, so one column, 800 lah. Okay. So 801 and 889 will be your test data set. So this is how you split your data. Okay. Okay. Now we will use the trend data set in order to model the data. So the formula that we will use will be binomial. Okay. So this is because we are using logistic regression. So the formula will be binomial. And remember that this is your dependent variable. Okay, your dependent variable here. This one. This is your dependent variable. Okay. So when you call the function GLM, so the LM is linear model, G refer to the logistic. Okay, so we are using logistic regression, and this one indicate the rest of the features, and the data that we get is from the trend. Yeah. Okay. So once we have modeled them, so we have this model. So when we look at the model, then we can say that, okay, the model that we have trained consists of this formula using binomial, and the data is coming from the trend. So we can see that this tree has significant effect on the survival because we have 3 stars. This is the level of confidence, which is 100%. Okay, so over here we have the P class, the male. If you are male, then you have higher probability.
Salam. Balik dulu kan? Oh, besok kerja lagi? Repeat lah. Turun sini dulu sebab tiket ada kat TBS, ada tiket kat KLIA. Tapi sebab nak hantar barang seorang ni, kita turun sini lah. Tak langsung jauh pula nak hantar ke TBS ke KLIA tu. Nak datang. Patutlah. Yep. Barang dia je saya bawa ni, barang saya mana ada. Sekejap.
Okay, doktor boleh proceed ya? Hello? Hello?
Okay. So we see that we have three features that are significant in forecasting the survival of that particular person. Okay. So now we have the model here. Okay, so we will use the model here to test the data that we have. So we will use the predict here. So we will perform the prediction of the model. Then we only use this data, excluding the survival features. And the type will be response because we are looking at 0 and 1 only. Okay, because we are trying to find the probability of one particular record fall 0 or 1 for the dependent variable. Okay, so this is the result that we get. So the result that we get, we can put here. So if the value is greater than 0.5, that means they are 1. If less than 0.5, then the value is 0. Okay. Okay. So how do we check how accurate is our data? Because this is the result that we get. Remember that in our test data set, we also have the actual data that we have. So we will compare the actual and also the predicted value for the survival features. Okay. So what happened here is I will find the mean average. So that means how many of those not matching. So this is the result that I get. Okay. And I want to see how many of them do not have the same value as the actual data that we have here. Okay. So I will get the misclassification error. So since I'm getting the error here, so the accuracy will be 1 minus whatever error I have. So I get this one. Okay. So in the future, when you have new data, so you just have your data to be inside this one, and this is the column that you have. Then you can show the result here for that particular item that we have. Okay, so let me run through this example so that you can follow the progress. Let me stop the sharing first. Okay, Can you see this? This is the R Studio.
Yes, I can see.
Mana tu
So
tak nampak?
we will set the working directory to be in D because the working directory consists the file that I'm looking at. Okay. So I will read the data from the D and have to look at the Titanic value. I find the file first. Where is the file? Wait, I noticed that my file is missing. Okay, let's try this one. Okay, for this statement, we are reading from the trend CSV, and yeah, we have the trend. Okay, trend. So we have the head true. That means we include the feature name, and this one we are looking at all the empty missing value will be replaced with a empty character, and then string as factor true. That means all the character will be maintained as factor. So if you look at the structure of the Titanic, so we have add9 one object 12 variable. This is your dependent variable. Okay. So this is factor and so on. So if we look at the missing value, we can check using the not applicable. So basically we are for each of the feature that we have, we sum up how many of them missing value. Okay. So we have this one. Okay. Then we decide to not to include the ID, the name, the cabin, and also the ticket number. Okay. So how do we select only a few column? We use the subset. Oh, before that, let's take a look at how do we map them. Is to install. Okay, so we can look at the mapping for the missing value. Okay, so from here we can observe the white row. Okay, so we need to settle all these three columns first. So the first one is we for the cabin, we will not select that one. Okay, so our data now will be only including all this. Okay, so if you want to look at the differences between the Titanic, so we have this one, Titanic. So this one we have passenger ID, survive, and then we have name and so on. But if we look at the data now, we have fuel. Yeah, we have fuel. Yeah. Okay. So we only select features that are relevant using the subset, and then now we will. Okay. So what happened here? I do step by step. So what happened here? It will give me the average of all the value for the age. So if you look at the age here, so this is the age. Okay, the age value. Okay, so we have NA. So when we say mean, so this one is basically taking the average age, not including the NA. So NA will not be counted. Okay. So what happened is that I will put this average into the missing value that I have. So how I do that? I just say this. So whenever I see this, I will put this value inside here. Okay. So
sorry Doctor, your audio missing, missing, slow sedikit. Boleh repeat?
okay, this one will take the average. Okay. So what happened is that I have this command. So whenever there is missing value here, so this is and a means is that cell is not applicable. So basically I'm talking about this cell. So whenever I see the cell is not applicable or missing values, so I will insert the mean average value of age into this particular cell. So basically I'm replacing the NA with the average. Okay. So if I look at the value for the age again, so no more NA. Okay. So previously I have this. I have many NA. Okay. So once we replace that one, if we do the mapping again for our data, so this is our data here. So we settle the age. We also remove the cabin number, and now we have this inbox. So we have 2. So this one is, for this one, we just remove the 2 rows. So how do we remove them? So we'll do this one. Okay. So if you look at this one, this statement will, okay, so this statement, what it will do, it will, for this particular features, if that particular features is missing, the value for that particular features is missing, so I will remove them. So that means this is not right. So my data here will include all data except the one that has missing value. So I will re-update my data here. Okay. So if I perform that one, I do the miss map. So now we don't have, but the number of value will be different already. The number of rows, because if we see previously, but cannot see here. Okay. But I can check my data. Okay. Now I have at 9. Previously I have at 9.1, right? So I have removed 2 records that has missing value for the inbox. So I only have at 9 now. Okay. So I'm ready to divide them into training and data set. So I will divide them. Before that, I should remove first the features. Okay. So this one, if we type this, it will give us. Let me go back. Okay. So this is as part of our column. So happen is that yeah. Okay, I off my video, right? Okay, so um so null means I will not include them in my data, so I just put null. Okay, so now I want to
So tidak nampak sharing screen, tidak ada.
sekejap, let me stop and share balik. Okay, boleh.
Belum lagi. Apa? Okey dah, okey dah. Nampak dah.
Yeah. Okay, so
Okey, nampak screen.
so now your data is clean already. So we want to divide them into training data set and test data set. So di sini we saying that okay, for row number 1 up to 800, I will put in the training data set. I did not specify the column ID here, so that means I will include all the column. But for the row, I only include 1 to 800 only. Okay, so that one for your training, and for the remaining, we will have the testing lah. Okay, so we have 2 data sets here, training and testing data set. So I will use the train data set to model the logistic regression. So over here, I will use the GLM. GLM is logistic regression. So this is my function. Survive is my dependent variable, and the dot here referring to the other feature, all the feature that we have. And the data that I'm using is the trend data set, and I'm using binomial because logistic regression using the binomial binomial formula. Okay, so if I model that one very fast, then if I look at the summary of this will tell you which column is important. So if you look at here, we have these 3, that means the P class, the gender, and the age. They are very significant in determining the survival of the person. Okay, since we have, when we estimate this one is basically we have all the coefficient for that. See all this coefficient. Okay, so we will use the test data set in order to look at the accuracy. So the test data set here, we will use the predict. So what happened here is that I'm going to predict using this model and the data that I will have coming from the test, but I only use all these features because I will not include the dependent variable, which is the survival. Okay, so I will use this one, and the type response is 0 and 1, in between 0 and 1. Okay, so I will predict the probability of that particular row given these all features. Okay, then the result that I get will be something like this. If I type this one, you will see not found. You see all this number? So all this number is basically the value that I get when I plug in all the independent variable here. Okay, so they fall within 0 and 1. So basically this value is the probability. So I need to convert them into 0 and 1. Okay, so for that one, I will say, okay, the fitted result, if they are greater than 0.5, I will put 1, otherwise I put 0. Okay, so if I type again the value here, now I have all 0 and 1. So this can be compared to the actual value that we get from the test data set. So we will do the matching. So we will do the matching. Over here, we are looking at the number of mismatch. So we are, okay, the fitted result versus the survive. So this one will give you the error. If you look at the error here, 0.157. So the accuracy will be 1 minus this value. Okay, so this is the accuracy. The accuracy will be 1 minus the error that we have. Okay, so this can be applied in any other classification problem. So when people ask you, can you use regression? Yes, if you use logistic regression, but no if you are using linear regression. Okay, so the difference between these two is linear regression, we use to forecast a number or forecast numerical values. Logistic regression is used to perform classification, and this is how we perform the classification. Okay. There is another type of regression. This is called regression tree. Okay. Okay. So regression tree were introduced in 1980s as part of the seminal classification and regression tree. So this one is more into how do we model a data in which use number but they have order. Like for example, we always give a comment about good, bad. So we have poor, and then we have fair, and then we have good. Okay, so this is 0, 1, 2. So this is considered as ordinal value because they have order. Okay, so let's suppose we want to model this. Okay, so we can use regression tree in order to model this because although they are numerical, but they have order. Okay, no, people give opinion based on this, based on poor, fair, good. But behind this scale, we have 0, 1, 2. Okay, so how do we model this one? Okay, so for example, we are looking at the quality of the wine. So the range is from 1 to 10. So 1 to 10. So people will do the wine testing and they give 10 if the wine is tasty, and 0 if not tasty. Okay, so depending on the input from the wine tester, they will look at all the property of the wine. Okay, and then they will try to model based on the feedback from the that they have. Okay, so let's have a look how we can use regression tree. Okay, in classification tree, what we want to have is when we divide the data, because in tree we normally have something like this, right? Okay, so when we have all the data here, when we go to left and right, we should have more homogeneity, means more data that are grouped together having the same class. So similar to here, if we go to left and right, so that means at the end of here we have class A, and this is class B, and this is class maybe A. Okay, so this can be used also for numeric decision tree, in which the homogeneity can be measured based on the variance or standard deviation. So meaning that if we go to left and right, the variance and standard deviation is very, very small. Means the perbezaan di antara satu sama lain itu is very, very small. Okay, so if you remember, variance is obtained by looking at the differences between mean and also the actual value of all the member. Okay, so in order for us to split the data, we need to compute what is the standard deviation reduction. So we want to minimize this. So this is the formula for the standard deviation before before you divide them into 2, and this is after you divide them. Okay, so we want to reduce this. We want to have a smaller value. Okay? Let me give you the example here. For example, here we have original data, the first row, and we can divide the data here using this feature A or feature B. Okay, so which one is better? Okay, so what happened is that I will find the mean for this, and I will find the variance for each of these two, and I add up that value, and I will compare with this. Okay, the total variance of these two. Okay, so if I go to the coding here, so basically this is the original data that we have. Okay, so I got all this, and then this is the splitting using attribute A. This is splitting according to attribute B. Okay, so one is here, splitting here, and the other one is here. Okay, okay. Now, based on this formula, we want to look at the standard deviation for the first one, the original one, which is this one. So for that one, we can use this one only. So this one, you give them the list of value for the T, and then the SD will compute the standard deviation automatically. No? And if you look at here, this is the standard deviation for the first, for each part of you have, and this is the weightage. Okay, for example, this one will compute how many member in that particular in here. So basically you have 9. So this is 9. And then the length of T will be 15. Okay, so this one will give you the weightage for this one for the first part. Okay, times what? Times the standard deviation of that particular. So this is the standard deviation of 81. So you will add all the number of partition that you have here. Over here we have 2 partition. So this one, the length of 82 will be 6 over 15. And this one is the standard deviation for the second part. Okay. So once we get the standard deviation here, so we will minus. Basically, this one we want to maximize pula sebab we want to have this one smaller and smaller, and we find what is the difference. Kalau difference is big, so that means we have improved the homogeneity of the group. Okay, so we compare the standard deviation for A and B. So this one is bigger, so that we choose this because we want to maximize this SDR. We want to maximize the differences between before and after. Okay, so that is the whole idea here. Let me give you the example for this one. We go back to here. Can you see this?
It's like the radio.
Okay. Tesla, standard deviation for 2, 2, 2. What is the standard deviation for this? Oh, should be this value. Okay. So the standard deviation for this is 0 because the mean is 2. So if you tolakkan dia dengan all the member in that one, it will be 0. So if we have another one, for example, this is 9 and then this is 5. So we will have bigger standard deviation. Okay. So the first example here is basically giving you what is T. Okay. So we have this T. Okay. So if we type T, these are the value that we have. So now let's suppose we create this at T1 and then at T2. Okay. So if we type at T1, basically this one consists the first part of the first 9 element for the T, and then the at T2 is basically the second part of the T. Okay. So if we look at the standard deviation for T, and then we have this. The standard deviation for 81, we have this. Standard deviation for 82, we have this. Okay. But this one is only the standard deviation. We need to also, okay, what is the length of 81? So the length of 81 is 9. So the length of 82 is 6. Okay. So the length of T is 9, is 15. Okay, so if we plug in all the value that we have here, so this one will give you the standard deviation. So this is the standard deviation of the T before you split them. This is after you split them. Okay, and then you look at the value for this one. So we have that. And this is the second one. BT1, BT1, BT1. Where is BT? 80. Oh, we haven't defined what is BT. So the BT is another one. So we have this. So this is the BT1 using different splitting. Then we can compute the standard deviation. Then standard deviation for B will be this. Okay. So if you compare the standard deviation for when we split using attribute A, we have 1.2. Then when we look at the standard deviation that we get when we use feature B, then we get this. So that means we want to use this because the differences of reduction that we get is bigger from the original one. Okay. Okay. So if I go back to the slide, so again, if I show you this formula, so basically we want to reduce, maximize the standard deviation reduction here, standard deviation reduction. Okay, so we want to maximize this. Okay, so if this one is X minus the whole thing Y, so we hope this one, we want to be very small so that we can improve this. Okay, so that's the idea. Okay, so like I mentioned just now, regression tree will model the data and form the trees for you. Okay, so let's take a look at the example here. So in this example, we have 4,898 wine. So for each of the wine, we have 11 chemical properties. And then the tester will have the option to give 0 for very bad wine to 10 for excellent wine. Okay. So if you look at this statement, we are looking at reading the data here. Okay, so if you look at the structure, we have 4,898 rows, and these are all the properties that we have. We have 12, I think 11 properties. Okay, and this one is the quality. The quality is ranging from 0 to 10. So this is your dependent variable. This is your dependent variable. Okay. Okay. So since we have ordinal values, meaning categorical value which has order, so we can use regression tree. Okay. So this is the histogram of the quality. So that means many people put 6. Okay, so nobody put 10 here, which is excellent, but nobody also put 0, 1, 2. So the quality of the wine is around here. Okay. Okay, so we divide them into training and testing. So we have this. So how do we get this number? This is up to you. You can put any number. Okay, so we can also do like 80% times the number of rows that we have. So this value you can put here. Okay, so we have training and test dataset. Okay, for this one we use the regression tree. So we need to install package rpath and then we upload into the memory. Okay, so how do we perform? Similar to the previous command, we will use this as our formula. So dependent variable and also independent variable. So in this case, the quality will be the dependent. This will be the dependent, the rest will be your independent. Okay. So we say quality and then dot means the rest of the features. Then we use the wine training dataset and we use the formula here for the regression tree. Okay. So once we get the model, so this is how the model looks like, but you need to look at very careful. So that means it said the root is starting from here. Then if the alcohol is less than this, we have this amount of data. If the name is wait. Okay, so this is the tree for this and this. If the alcohol is less, then we go here. If the alcohol is greater than 10.85, you go here. And then you check again this one. So this is the result that we get. But in order to plot them, it is easier to look at the result here. So we use what we call the rpath plot. The rpath plot will say, okay, if you are here, so if the alcohol is less than 10.9, so you go here. Okay, if the volatile acidity is greater than 0.22, you go here. Okay. So over here, the value of the quality is 5.26. So meaning that if you want to improve your wine, that means you can control the number of alcohol, the number of free sulfur dioxide, and also alcohol again, and so on. Okay, so this is what we get. Okay, so this is a very interesting modeling because you can visualize and you can look at why people give 1 or 2 or 9 and 10, because this answer is very subjective. But if you can do some experiment to explain why people say 10 or 9, so we can look into the property of the wine that we have. Okay, so this is another one, another way to visualize them. Okay, so once we have modeled them, then we can use the predict. So the predict is used to take the model that we have modeled, we take the wine. Okay, so what we want to do is we want to know how much the results are correlated to each other. Okay, so this one will perform the prediction. We get the P here. This is the hasil from the prediction. Okay, so this is for the quality that we get for the prediction. This is the actual one. So we want to know what are the correlation between these two. So what we can do is we find the correlation between the predicted one and also the actual one. The correlation is 0.5. So that's how we quantify the quality of the regression tree that we have. So maybe we can remove some features or add some more features in order to increase the correlation between the predicted quality and also the actual quality. Okay. So for me, this is very interesting because they are very interesting because easy to use for modeling complex data like this, like why people happy, why people not happy because of the service and so on. So we can include all the features that we have collected. Very interesting. So you can create a simple project for this one. For example, you want to do survey, and then you have a scale like it 1 to 5, but you want to quantify why people say 5, why people say 4, why people don't like, but you also need to collect some other features that we have. So very interesting. The first part is quite normal, in which you're trying to do the classification. Okay. So any question? 11:30 already.